The next thing we're going to discuss is representing coordinates on the coordinate plane and complex numbers on the complex plane. They're extremely similar, and complex numbers are not complex in this case. A coordinate plane is a plane determined by a horizontal number line called the x-axis and a vertical number line called the y-axis, intersecting at a point called the origin. An ordered pair are two numbers written in a certain order. Ordered pair, ordered, usually written in parentheses, like this, with the xy here. Notice how that has xy. The x is the horizontal value on the x-axis, and the y is the vertical value on the y-axis. The point xy is where these two values meet. So now we want to graph the coordinates on the coordinate plane. So our first number is 3, 4. So we count 1, 2, 3 on the x-axis, and then 4 vertically. 1, 2, 3, 4. So our first number goes right here, and it's 3, 4. Like that. Our second number is 4, 5. So we count 4 on the x-axis. 1, 2, 3, 4. 1, 2, 3, 4, 5. And that goes up there. And it's 4, 5. Our next number is negative 3, 2. So just like when we were doing numbers on the number line, the negative was to the left and the positive is to the right. So now we're going to count negative 3. So negative 1, negative 2, negative 3, and positive 2. So we go up 2. So this number is negative 3, 2. Now we have negative 2, negative 4. So we're going left 2, 1, 2, negative 2, and down 4 because it says negative 4. So negative 1, negative 2, negative 3, negative 4. So our point here is negative 2, negative 4. Our next point is 0 on the x-axis, so we don't move left or right, but we go up 4 because it's positive 4. 1, 2, 3, 4. So our point is 0, 4. And the last point is negative 3, negative 1, negative 2, negative 3, and it's 0 for the vertical, so we don't move on the vertical, so it's just negative 3 and 0. This one that we just finished, we assumed that the increments were 1 on the x values and 1 on the y values. Again, just like our number lines, we could have different increments. So here, let's make the x increment not 1, but let's make it 10 because these are all the x values are multiples of 10. 30, 40, negative 30, negative 20, 0, and 30. So we're going to make our x increment worth 10. And our y increment worth 100 because all of these values, all of the y values are multiples of 100. 400, 500, 200, negative 400, 400, and 0. So now, if we're going to count by tens on the x value and by 100s on the y-axis. So 30, 400, we have 10, 20, 30, and then 100, 200, 300, 400. So our point here is 30 and 400. And then we have 40, 500, so 10, 20, 30, 40. And then we count up 500, 100, 200, 300, 400, 500. So this is 40, and 500. Our next one, we have negative 30, negative 10, negative 20, negative 30, and positive 200, 100, 200. The next value we have is negative 20, negative 400, so negative 10, negative 20. And then down 400, negative 100, negative 200, negative 300, and we have negative 400. Now, the next one we have 0 for the x. Again, we don't go left or right, but we want to go up 400. So 100, 200, 300, 400. And then the last one, we have negative 30, negative 10, negative 20, negative 30, and 0 for our y value, so we don't go up or down. Notice the points here and the points on the previous problem are the same points. It just differed by the increment. So let's try this one. For this one, we want our x increment and our y increment to be the same, but it's going to be fifths because that's what our denominator is. That's what our common multiple is. It's 1/5. So just like when we had the fourths and the eighths in the last session, our common denominator is fifth. So we're going to use fifths as our increment. So now when we count, we're counting 0, 1/5, 2/5, 3/5. So this is 1/5, 2/5, 3/5. Same. 1/5, 2/5, 3/5, 4/5. So now when we have 3/5, 4/5, you have that point right there. Four-fifths and 1 is equal to 5/5. So 4/5 and 1, we have 4/5, 3/5, 4/5, 1, 2, 3, 4, 5. That's 5/5. So that point is 4/5 and 1. And then we have negative 3/5 and 2/5. Negative 1, negative 2, negative 3/5, and positive 2/5, negative 2/5 and negative 4/5, 0 and 4/5, and negative 3/5 and 0. And if you look here at the points on this one and the points on the previous two, the points are all in the same spot again. It just depended on what our increment was. Complex planes are very, very similar to the coordinate plane, but this time the horizontal axis is the real axis and the vertical axis is the imaginary axis. Other than that, when you plot complex numbers on a complex plane, it's exactly the same. So if we have 3 plus 4i, if we want to plot it, that's the same as 3, 4 if we're plotting it on the x on the coordinate plane. So 3 plus 4i is 1, 2, 3 over and 1, 2, 3, 4 up. So this is 3 plus 4i. 2 negative 3 minus 3i is 2 and negative 3. So 2 over, 1, 2, and down 1, 2, 3. This is 2 minus 3i. 4i is going to be 4 up on the y-axis or the imaginary axis. because there's no real portion. And negative 2 is going to be negative 2 on the real axis. So that would be the point 0, 4i and negative 2, 0. Distance. We have this really complicated formula for distance. Distance is equal to the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. This is a difficult formula to remember. It's a lot easier to see the why. Why is this formula the way it is? And where it comes from and apply it. Most people remember the Pythagorean theorem is a squared plus b squared equals c squared. This is where the distance formula comes from. So let's look at where the distance formula comes from and how to apply it. The midpoint formula, and the midpoint is the point that's exactly in the middle of two or more points on a plane. To find the midpoint, you need to average the x values, so we do x1 plus x2 over 2, and then average our y values, y1 plus y2 over 2. So this is the formula for it, but the reason why we're doing this is because it's the middle, and to find the middle you need to take the average. So let's graph these points and then find the distance in midpoints. So for 2, 5, we count over 2, 1, 2, and up 5, 1, 2, 3, 4, 5. But we're going to have a problem because we have to go up to 9 over here. So our increment here is, let's make it 2 instead of 1s. So we're going to count over 2, and then we're going to count up 5. 2, 4, and 5 is directly in the middle. Now we want to plot 5, 9, so 2, 4, 5 is in the middle, and then 2, 4, 6, 8, and 9 is in the middle. So our other point is right there. So here's our 2 points, and we want to find the distance and midpoint between those 2 points. So let's look and see what happens when we have a triangle, because that's how we find the Pythagorean theorem. From here to here we have from 2 to 5. So the distance here between those 2 points is 3. From here to here we have 5 to 9. So the distance between those 2 points is 4. So for distance, let's use the Pythagorean theorem instead. Because we know that from here to here is 3, and this is a right triangle, and here to here is 4. So we're going to do 3 squared plus 4 squared equals, we'll make that c squared. So 9 plus 16 is equal to c squared. So 25 equals c squared. So c, what number squared is equal to 25? So c equals 5. If you wanted to do the distance formula, erase this so we have some room. You would end up getting the same thing. So remember, distance is equal to the square root of the difference of the x values. So we're going to do 5 minus 2 squared plus the difference of the y values, 9 minus 5 squared. So that's equal to the distance. Distance equals the square root of 5 minus 2 is 3 squared plus 9 minus 5 is 4 squared. Remember, we had a 3 squared and a 4 squared in the other formula, in the Pythagorean theorem way we did it. So that's a square root of 9 plus 16. So that's the square root of 25, which is 5. So you could do it either method. Sometimes it's a lot easier to see it doing it the Pythagorean theorem way, just because that way you don't have to memorize the big formula. Now we also have to find the midpoint, so I'll erase this again. If you need to, you can rewind and take notes again. Just go ahead and do that. So our midpoint is the average of the x values. So our x values is 5 plus 2 over 2, and our average of our y values, 9 plus 5 over 2. So that's 7 over 2 and 14 over 2. 14 over 2 we can simplify to 7. So we have 7 over 2 and 7. And if we look, 7 over 2 is 3.5. So this is 2, 4, 3 is right here, 3.5 is about right here. And then 7, 2, 4, 6, 7. So that's about right there. So that is where the midpoint of those two lines is. Next, we're going to talk about the absolute value of a complex number. Remember, we talked about absolute value a while ago, and absolute value was the distance from 0. So, the absolute value of a complex number is the same as the distance from 0 as it would be two different points on a plane that we just did. So let's see how we do that. 5 plus 12i, we're going to plot as, let's see, we have divisions of 10. So for the x values, we'll make it worth 1, and the y values will make worth 2 for this first one. So we have 5 plus 12i, so 2, 4, 6, 8, 10, 12. And we want to find the distance or absolute value from 0. So from here to here is 5, and from here to here is 12. Again, you can use the distance formula, or we can use the Pythagorean theorem. So I'm going to use the Pythagorean theorem. So 5 squared plus 12 squared equals c squared. 25 plus 144 equals c squared. So 169 equals c squared. So c is equal to 13. 13 squared is 169. So the distance, or the absolute value of this number, so we can write it as the absolute value of 5 plus 12i is equal to 13. Looking at 3 minus 7i, this one will just keep the increments as 1 and 1. So 3, 1, 2, 3, minus 7i, 1, 2, 3, 4, 5, 6, 7. That's down here. And then we have this triangle. Let's try that again. 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And then we're going to have this, we want this distance here. So we're going to go from here to here and here to here. This distance from here to here is 3. And even though this is negative 7, the distance is actually 7. So we'll do 3 squared plus 7 squared is c squared. So 9 plus 49 is equal to c squared. So 58 equals c squared. So that means c is equal to the square root of 58. And you can stop there because that's actually an exact answer. We don't need to plug it into a calculator. And that's it for today. Talk to you tomorrow.